Hello everyone and welcome. Today I'll be talking about binary tree in-order traversal. The question is pretty straightforward. Given the root of a binary tree, return the in-order traversal of its node values. Previously on this question, I've made a video and the solution is based on iteration or recursion. It has a time complexity of n and a space complexity of n as well. In this video, we would like to challenge ourselves. We ask, can we achieve space complexity of 1 extra space, not counting the resource array though, without using any stack for recursion or iteration? And the answer will make this question a medium level question. The answer is based on Morris traversal. In another question, flatten binary tree to link this. I also use this technique. Please feel free to look up this other video for more details. First, we would like to remind ourselves in each tree node instance, there are two pointers, left pointer and right pointer. And then, based on this idea, Morris traversal, or sometimes known as threaded binary tree, is simply to rewire the connection in the original tree to a new arrangement. In this question, the new arrangement is a tree that will give us the in-order traversal. There are three steps here. Step 1. So first we look at the left child and the right pointer of this left child. We want it to point to the original node. And then we also keep where the left child is pointed, the left child in its original left variable. Second, we point the left pointer of this original node to none. Third, we have the node point to this original left. After these three steps, we have a new arrangement that will give us an in-order traversal. We will now up the ante and consider a slightly more complicated case, a tree with 7 nodes and a height of 2. We'll be following the same 3 steps above. The only difference in this set of code is that we are pointing the rightmost child of this left child to the root node. And after this rewiring, we have a tree on the right hand side. Although the tree on the right hand side does not give us the in-order traversal just yet, if we repeat these 3 steps one more time, with the root node now is node 2, then this node 1 will become the parent of node 2, and the right child of node 1 will be pointed to node 2 and get us closer to in-order traversal. Now we will consider a more general case. In this case, we have the 3 lines of code here. They will give us the rightmost leaf of the left child node, and then we'll point the right of the rightmost leaf to the root node. And after this whole set of lines of code, we will be able to rewire the original tree to a tree that gives us something a lot closer to in-order traversal. Now we will increase the complexity of the code just one small step further. On the left hand side, we see the evolution of the code to rewire the tree when the left child node exists. But what if there's no more left child node? It means we have reached the leftmost leaf node of the left subtree, and in that case, we'll start to record the node value to give us the in-order traversal. So by the last 3 lines here, we'll record append that value to a resource array, and then move to the next node as the right child node. With all the background introduced, now let's write the code. First of all, we'll initialize a resource array. And then we want to remind ourselves the simple 3 steps for Inorder Traversal rearrangement. So if the left child exists, then we want to point its right pointer to the node itself, while keep a copy of the original left. And then we will have the left pointer of the original node point to none. Finally, we have the original node now point to the original left. And then this is our simple example with 3 nodes. And then we'll now up the ante and make it a general case. So we have a rightmost equal to the left pointer of the original node. And this is the rightmost pointer or leaf of the left child. And to get the rightmost part, we'll do a while loop. While rightmost still have a right child available, then you will move on to its right child. And then here we'll replace this rightmost right pointer to the original node. And this is a general case. And then if the left child does not exist, then we will move on. Well, first of all, record the value of the node, and then move on to the right child of that node. And we also want to have the node point to the loop in the first place, and do a while node, the loop, to go through all the nodes in this tree. Finally, we'll return the resource array. Now, let's test this to see how it works. We submit, and it's done. It has pretty good memory performance here, as expected. Finally, we'll analyze the code for complexity. For time complexity, is considered to be O(n), since we use a while loop to iterate over each of the nodes at least once. Some of the nodes may be visited 2 times, but it's still considered to be linear to n. And for space complexity, importantly, it's a Morris traversal, and it has a O(1) extra space, since we basically is to rewire the connections between the existing nodes without creating new node data. And we use extra constant space variable here, such as rightmost or original left. And that's all for this video. Hope you find this video to be useful. Please subscribe for more videos. Hope to see you next time soon, and goodbye.